The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone, and welcome to today's webinar, which is entitled Building Stronger Food Safety Programs Through Next Generation Sequencing. My name is Brian Bedard, and I'm the Executive Director for the GMA Science and Education Foundation, the host of today's webinar. The GMA Science and Education Foundation is a nonprofit organization with a mission to support education, research, and training that impact the food and consumer packaged goods industry. Today's webinar is sponsored by Clear Labs. If you have any questions during the webinar, we'd ask you to hang on to those and they will be answered at the end of the webinar. So for any questions you might have, please type them into the chat or question window that will appear on your screen. Just for your information, all of those that are listening in will be muted during the course of the webinar so that we don't have any conflict with the speakers. And for today, we have two speakers. We're very pleased to introduce two speakers, one being Dr. Mani Gurashi from Clear Labs, and the second being Dr. Lawrence Goodrich from McGill University in Montreal. Mani Gurashi is the co-founder of Clear Labs, where he leads commercial activities including strategy, marketing, and business development. After graduating from MIT and getting his MBA, Mani pursued his interest in big data and genomics as head of marketing at Vena Technologies. He is the co-founder of Clear Labs, which is intended to set a new standard in molecular quality for the global food industry. Dr. Goodrich received his PhD from the University of Guelph with a major emphasis on food microbiology and food safety. Following that, he did a postdoc at the University of Georgia and held faculty positions at the University of Wyoming and Colorado State University. Dr. Goodrich is currently an associate professor in the Ian and Jane Munro Chair in Food Safety in the Department of Food Science and Agricultural Chemistry at McGill University in Montreal. So without any further ado, I'd like to hand this now over to Mani to begin the presentation. Please, Mani, go ahead.
Thank you so much, Brian, for that kind intro, and to Professor Goodrich for joining me as a panelist on today's session. It's a real pleasure and honor to be here to discuss with the attendees on our topic today of building stronger food safety programs through next generation DNA sequencing. So with that, diving in, probably many of the attendees today are familiar with advances in genomic sequencing just through public news sources, but we've come an incredibly long way from the Human Genome Project, for those who recall, which was a 13-year, $3 billion initiative to sequence a single human genome, and now we can do it for less than $1,000 for a human genome, and the cost continues to fall. As you can see on this graph, we're comparing sequencing technology advances to Moore's law, which is the computing advances in processing chips that has given rise to the Silicon Valley and all the big software companies that we love and use every day, and you can see how much faster sequencing costs are advancing. And so this technology is imminently being rolled out into the food industry and is going to play an increasing role in food safety and quality programs in the years to come. And today we can sequence food samples for tens of dollars a sample, and soon that's going to fall to cents. If you look at the global food safety market, it's a roughly $10 billion market. And a huge percentage of that market is devoted to pathogen and indicator organism testing, GMO testing, and other types of non-DNA based molecular methods. And next generation sequencing is really poised to disrupt legacy technologies like PCR and ELISA and other de facto methods as the dominant mode of DNA based safety testing in the years to come. We're also sitting at the intersection of some major market forces that make this platform and timing quite ideal for next generation sequencing. So as many food company attendees know, there's a rise in consumer demand for more transparency and traceability into the foods that they're eating, and to have more information and to be more empowered about whether foods are in fact safe or GMO-free or whatever the question might be in their minds. Certainly the global supply chain is becoming more complex as we move to feed a growing population of 9 billion people by 2050. And then, of course, all of the regulatory implementations, including, of course, the Food Safety and Modernization Act here in the U.S., and other moves globally on a regulatory scale to really put more preventative controls into place and to build stronger food safety programs via regulatory implementation. So it's the intersection of all these powerful forces are coming together and really setting the stage for next generation sequencing as a very powerful tool for building stronger food safety programs. On the technology side, we're seeing certainly incredible advances from sequencing technologies being able to do what are called multi-marker or targeted DNA sequencing. So when we talk about next generation sequencing, it's actually a very broad umbrella of applications, of which whole genome sequencing is only one type. I'm sure many attendees today are familiar with whole genome sequencing, especially with the FDA's genome tracker. But that's only one application of next generation sequencing, which lets you go really down to the strain level of pathogens and being able to correlate things like resident versus transient strains, et cetera. But next generation sequencing is much broader than that. And there's a type of sequencing that's now being rolled out known as targeted NGS testing, which can be very specific in terms of the information that you can gather. For example, things like food authenticity, looking at pathogen types, but at the serotype level, so not going down to the very deep strain level as you get with whole genome sequencing, GMO testing, and a host of other applications. And then certainly the rolling out of new molecular food databases of genomic markers and software algorithms to be able to support this type of testing at scale is really providing the technology backbone to make this revolution happen. This webinar is divided into three large sections. The first, we'll dive into supplier verification testing. The second, we'll look at R&D applications, and then finally at food safety. But before moving into each of the detailed sections, I wanted to let my co-panelist, Professor Goodridge, chime in with any high-level thoughts you might have on the potential of NGS before we dive into detailed applications. Larry, did you want to add any commentary here?
Hello?
Yes.
Can you hear me?
You are.
Okay. Sorry, I was just on. Yes. Yes, just to agree with what Manny has said, you know, I think we're still at the beginning of this journey with NGS technologies. He certainly has highlighted what's been done so far, and has touched a little bit on the fact that that is only a small amount of the ability of this technology. The cost, well, you know, I always get questions about the cost, and so I think it's important to understand that, and to re-emphasize that as although the cost is still, you know, compared to other rapid methods, other pathogen rapid methods, for example, the cost is still much more expensive, several times more expensive. To reiterate what Manny said, the costs have come down significantly and continue to, and you know, I think that in a fairly short time frame, not only will the costs rival that of traditional pathogen tests, but will also be cheaper than that. So what we're looking at is a technology that can give you much more information than traditional pathogen tests, which tend to tell you presence or absence. With a DNA sequence, not only do you know what's there or not, but can give you much more information. For example, if we're talking about bacteria, about the serotype, about antibiotic resistance, which is becoming something that's very important now in the food industry. So all of that information, you know, for potentially much cheaper than the tests today, which give you very limited information.
Perfect. Thank you so much, Larry. Fantastic commentary and insights, and completely agree. So let's dive into part one of our talk on supplier verification, which is primarily we're going to look at applications, as I mentioned, under the umbrella of next-gen sequencing. There's a type of testing, targeted NGS, which is very applicable to things like food authenticity and GMO testing and supplier verification applications. So we're going to dive into that first. And of course, the big issue here is around food fraud, which estimates occurs up to 10% of the time in food types, and to cost the global food industry between 10 to 15 billion a year. And of course, there's significant consequences to brand damage, to public health risk when we're dealing with allergens that are undisclosed within a food product, and a recall cost, on this scale is estimated to cost between 2 to 4% of a food company's annual revenue. And of course, food fraud is a key topic today with FSMA, with preventative controls around economically motivated adulteration, which can introduce food safety hazards, and even the GFSI in February of this year has issued document guidance on food fraud requirements. So the regulatory backbone is coming into place for this particular application of NGS. I mentioned allergens because this is such a common problem in recall incidents, and a really interesting statistic that may not be intuitive is that undeclared allergens have actually become the #1 reason of recalls in recent years. And if you look over the last few years' trajectory from 2011 to 2015, you're starting to see, Salmonella, Listeria falling behind undeclared allergens as an indicator of recall costs or recall needs. And so NGS, when it comes to things like food authenticity and ingredient verification, is an extremely powerful application to mitigate against this risk. Here we're looking at some kind of success stories, if you will, or case studies, just to show you how the technology can work. So here we're looking at a beef pork meatball, and one of the real powers of next-gen sequencing is the ability to look blindly into any food sample and to discern all of the ingredients that can be present within that sample. It's non-targeted compared to PCR testing. So you're able to literally look for millions of organisms, plant, animal, bacteria, fungi, by combining these cloud databases with this type of universal untargeted testing. So here you can see we've teased out all the ingredients: pork, beef, onion, potato, etc., and then flagged alerts. So missing ingredients which were claimed to be present on that sample, and then an allergen, here in this case soybean, which was not among the listed ingredients. So this is just one example of many of the ways that you can see an incredibly rich data set within food samples leveraging this technology, and in particular in the allergen use case. Here we're looking at a ground white pepper sample. This is a classic food fraud case study. We have detected, large quantities of black pepper, but an unexpected allergen on the wheat front, and more interestingly, major quantities of rice adulteration. Rice is heavier by weight and the same color as white pepper. No one would have thought to sequence for or test for rice within a pepper sample, but again, being able to leverage NGS and look blindly into a sample, you're able to detect these rare and unexpected adulterants that could be present within a sample. So it's a very powerful tool for food fraud, without question. And then, as we discussed, a lot of the issues around recalls come about from supplier mislabeling or mismatch between what's actually within a sample and what's listed on the ingredients and labels. So Here we're looking at an authenticity report for a vegetable mix, and again, you can tease out all of the different plant species that are present here, and we flagged unexpected alerts for parsley and onion, which were not expected within the sample. Again, this could very well be an allergen case that could trigger a recall event. So that's a quick run through of the supplier verification use case, and wanted to pause here and let Larry chime in on what he's been seeing on the academic front and industry front around food fraud and adulteration and GMO testing. We didn't talk explicitly about GMOs in these slides, but that's certainly another application that is catching fire with NGS, because as opposed to PCR methods, which are targeted again and go one gene at a time, you really can't validate that a product is in fact GMO-free with any confidence. But now with next-gen sequencing, the ability to look across all known published GM events within a crop or sample, you're able to get very, very high confidence in a scientifically validated test to in fact validate that products are GM-free or not. And certainly this is of huge interest to certification bodies who can now compete with the non-GMO project and other standards leveraging NGS technologies. And so it'll be interesting to see where this goes on the GMO front as well. But Larry, would you want to chime in on some comments on food fraud and GMO testing and what you're seeing in the field?
Sure. So I just want to come back to your contrast between NGS and PCR and really highlight that, because I really think this is this area is really where NGS really shows its true colors and its capabilities. So, as you just heard, current methods for detection of adulterants in food, whether it's food fraud or GMOs, are really PCR based, and that is the good news of that. The advantage of PCR, of course, it's a well-known technology. It's mature. It works. However, there are disadvantages as well. You have to know what you're looking for. So in the case of a food fraud event, we just saw some examples of, for example, the pepper with the rice. If you didn't know to look for rice, then PCR assays, and the other thing about PCR assays is, so in developing the assay, you have to know what is being used to adulterate the food, so you can develop a targeted detection for that adulterant. So in this case here on the slide, the pepper, white pepper, if people were not aware that rice was being used, then the PCR test would not, let's say it may have been produced to detect the wheat, but not the rice. So you wouldn't know that. Another real world example where that happened was the horse meat scandal in Europe. In 2012 and 2013, where it was well known that beef was being adulterated, but it was thought mainly that was being done with pork. So there were PCR assays to detect the pork in beef. Nobody thought that horse meat was being used. So that went undetected, and potentially for years, until authorities were made aware of that, and then the PCR test had to be designed to detect the horse meat. So basically, the analogy I like to put, discuss or compare PCR testing for food fraud and GMOs to, is the Olympic Games, where you have athletes and some of them may be taking legal drugs, and the drug testing lab has tests. Sometimes they don't have tests for that drug, so the athlete gets away with that, and it's years later they come up with a test to detect the drug, but the doping has already occurred. That's, to me, the same situation with PCR. It's reactive. Now let's contrast that to NGS, where, as you heard, you can look for anything. if you sequence all the DNA or markers that are consistent with all the DNA in the sample, then you can find multiple species simultaneously. That is, so the major objective, or the major advantage there is you do not have to know what is being used to adulterate the food. Not only that, but adulterants can change over time. People can move to different foods or substances to adulterate the food. So it's much more of a preventative situation than PCR, which is reactive. And the same thing goes with GMOs, as you've heard. There are many foods that are being genetically modified now, and so that means that in a food sample, like a plant sample, you could have there's a potential for multiple species to be present that are genetically that came from a genetically modified organism. So this is really where I think NGS really shines and really will show its capabilities. With respect to what I've been seeing and what I've been hearing, you know, I think we've seen some pretty good examples of what the technology can do, and what what foods are adulterated. Certainly, plant-based foods are a big deal. Spices, oregano, for example, and other spices. But where I really think, from an academic standpoint, what has to happen is in standardization of methods. Because right now there's no real standardized method or approach used to detect food fraud. So I think this is another advantage of NGS as it goes forward. You know, the protocol, essentially the protocols for sequencing DNA are pretty standardized, as opposed to, let's say, a PCR, where for a different PCR assays there could be different conditions needed for the assay to work, and different primer sequences and so forth. We're talking about sequencing DNA. You know, the standards are pretty well agreed upon. There's only a few companies that make the actual sequencing technology. Really, at this point, I guess I would say two main companies. So I think for the prospects for global standardization of using NGS in these capacities is well along its way.
Thank you, Larry. Fantastic. And so the next section I'm going to go through fairly quickly on R&D applications, because I do want to spend a great deal of time on this webinar on safety, you know, the big whale around how NGS will eventually find its way into routine testing, you know, product testing, environmental sample testing, and how targeted sequencing using NGS differs from whole genome sequencing, which is only one application of next-gen sequencing, and is certainly a popular topic today. And so I really want to spend a great deal of time on that. But for those attendees who are in R&D departments and product development departments, I did want to touch on briefly about how NGS is being used in R&D applications today in new product development, particularly around new health foods, as this trend becomes larger in the industry. So again, one of the advantages of next-gen sequencing is the ability to go very broad across a number of questions that you would want to see within a food sample: ingredients, allergens, bacteria, fungi, plants, GMOs, etc. That's the breadth of a targeted sequencing approach that we've been discussing, a theme on this talk. But the other ability is to go very deep, which is using whole genome sequencing, one application of NGS, and that seems to be one of the most popular or most talked about, I'll say, applications of NGS today in the food industry. It's somewhat controversial, of course, in terms of holding on to this strain typing that can go quite deep and can be used and involved in the linkage of an outbreak. And so there's a lot of liability concerns around using whole genome sequencing in food safety programs to date. But it is one tool in the armament, and certainly you know, I'm a big believer and proponent that the targeted sequencing, which can give you just the information that you want at the accuracy levels that you want will ultimately prevail, but we'll see how this market evolves. But this combination is quite a powerful one, and very applicable when you start to take the results of these test results and marry it to product metadata in terms of, where is the product coming from, its origin, its ingredients, its nutritional data and label claims. This is all through software and data analytics. And you're able to do really powerful things like monitor, for example, formulation consistencies over time in terms of products and how that's shifting. Certainly one very powerful application that you can graph. Looking at organic versus non-organic products, which have different microbial signatures. So as it turns out, all of the microflora, the bacteria and fungi that grow on food products have a different microbiome than in their organic counterparts to their non-organic counterparts. And so as sequencing becomes cheaper and faster and more portable and mobile, it will be fascinating to watch how this, might ultimately displace, things like pesticide testing that have been used to date for organic food testing and integrate it into more routine applications. Certainly how diet correlates with causal agents of disease is another area of huge potential, particularly in creating health foods and probiotic and prebiotic enriched foods. You're able to correlate, for example, specific types of bacteria and fungi across different ingredient types, and to create and monitor foods for either for risk of aggravating symptoms like Crohn's disease, but also to avoid those types of risks in new health foods. And you can really start to ask really fascinating questions. For example, where I tend to find one type of ingredient where X can be, where do I see Y? And to start to create large-scale matrices and databases that can then start to correlate these types of ingredients and questions, which are fascinating. For example, looking at probiotic-enriched foods, which ingredients are highly associated with specific probiotics, and how can I start to engineer foods that have the highest likelihood to carry these probiotics into health and diet questions. And so here we're looking at one very small corner of a massive database or table of ingredients versus probiotics, and you can see through a kind of heat map format where you are more likely to find specific probiotics versus their ingredient counterparts, which is obviously invaluable data as companies like the largest manufacturers in the world are starting to really rebrand themselves as health food companies. And so there's no doubt that NGS is going to start to play and is already playing a huge role in this type of R&D research. And of course the holy grail is ultimately diet, the intersection of diet and the microbiome, and starting to build personalized diet recommendations and looking at the correlation between diet and stool samples for research. And this is happening quite vigorously in academia today with labs around the world, with academic researchers looking at these intersections and really needing platforms that have standardized bioinformatics and microbiome capabilities for standardizing the research and for being able to create reproducible results, and so that they're not having to build custom in-house solutions every time. But anyway, this is certainly a big area, and I do want to save about 30 minutes or so for this webinar to really dive into food safety. But Larry, did you want to add anything briefly on the on the area of the microbiome and what you're seeing in academia?
Yeah, so absolutely. But I just, before I get to that, I just want to touch on one comment you made, Lenny, which was, the potential liability of using next generation sequencing technologies in food safety applications. So this is something that I hear a lot from the food industry. Something that, you know, people say, well, this seems like interesting technology. It seems very powerful, but, you know, I'm a little concerned that if we sequence our whatever in our foods we have for contaminants in our plant, and we find those, that if there's a subsequent outbreak or a recall or something, and the government, the FDA or USDA seizes those results, we could be liable. So I always like to say that, yep, that's potentially the case. However, that has always been the case. This is not something that's specific to next generation sequencing. You know, pulse field gel electrophoresis, which is currently being used in terms of microorganisms to determine relatedness and track contamination through plants and food plants, I mean, and ribal printing, automated ribal printing, another method to do that. These methods have been around for years. They create fingerprints. And next generation sequencing has a higher resolution and is more discriminatory, but these technologies also create fingerprints and information. So potential liability has always been there, and for companies who are using those technologies, the liability would be the same. So I think that's something that is a little bit unfair to just place right on the next generation sequencing side. With respect to microbiome, again, this is another area where I'm really excited in terms of next generation sequencing. You know, we now understand that in a respective food sample, there can be multiple organisms present that are pathogens or contaminants. So, you know, the traditional approach was to identify a pathogen with a food, come up with a risk analysis. Is that food a high risk for listeria, for example, or Shiga toxin producing E. coli or salmonella, and then build your testing around that. But we've seen foods that are vehicles for multiple pathogens. Cantaloupe, for example, caused a major outbreak in 2011 in Colorado with Listeria monocytogenes, and in 2012, cantaloupe caused a major outbreak in Indiana with due to salmonella. So multiple pathogens can be found in the same food, which means that testing for the safety of those foods should now be can consider that and should detect multiple pathogens, which traditional methods struggle to do. So there's that. The other side of it is quality. And I think, you know, and this again is something where for sure we know that multiple multiple bacteria are responsible, and not just bacteria, but other microorganisms, fungi, for example, are responsible for spoilage of foods. And that tends to happen in a stepwise manner. That is, not all the microorganisms that spoil the food will be at high numbers at the same time. So you can use NGS to monitor that and perhaps determine the shelf life of a food as part of the testing regimen, so that if for example food is contaminated with a high number of spores microorganisms, such that the shelf life will be much shorter than what it should be, then perhaps that food is not shipped to retail. Because it'll have to be recalled because it's spoiled, you know, before its shelf life. So that's another example. With respect to the human gut, we now understand that the human gut is a major organ in the body and probably controls a lot of the bodily functions, and is you know, the microorganisms in the gut are probably implicated in a number of diseases that we see. And I don't just mean infectious diseases, but diseases like obesity and diabetes, Crohn's disease. And we also know that, of course, the bacteria in the gut, in the microbiome of the gut, is related to the foods that one consumes. So this is now opening a whole new field, as Mani talked about, in terms of being able to not only make sure that foods may not contain a bacteria, which, while not a pathogen, may contribute to the cause of a chronic disease, but also I think now we get into tailoring foods and this is where probiotics come in, as well as prebiotics, to ensure that foods are being consumed by people at the very least high risk populations. Those foods are tailored to ensure that those people will obtain the maximum nutrients from that food.
Thank you, Larry, and I certainly agree with you that shelf life studies around the microbiome are increasingly an area of huge potential and of huge concerns for food brands as they want to maximize and to really analyze and have some detailed molecular analytics on the potential of shelf life of products to route through various channels ultimately to the end consumer. So that's certainly a very exciting area. Finally, we want to wrap up and spend most of our time on the food safety question and market, which is obviously the largest component of the food testing industry. And here again, I really want to emphasize for our audience the differentiation between whole genome sequencing, which is one application of NGS and enables food brands to go very deeply into the genome to characterize the strain of a pathogen. And this can be used for identifying resident versus transient strains, or if in the event of a regulatory purpose it's involved in a food outbreak, to link a particular isolate to an outbreak. That is one application of NGS, and is very useful for going very deep and getting some very specific data, but of course it carries a huge amount of liability for food brands, and there's a great deal of caution being exercised in the market around this application of NGS. But the other really key application of NGS that I want to hit on is it goes back again to that type of targeted sequencing, where you're identifying very specific regions of the genome to amplify and sequence, which give you just the amount of information that you would want for a food company. For example, the pathogen species, its serotype, its quantification, and leave it at that point without going deeper, so that you're getting a richer information set than your existing methods for routine testing, PCR, ELISA, whatever it may be in your product and environmental testing programs, and give you much lower false negative and positive rates for accuracy. So we're going to dive into this discussion a little bit deeper, and where the technology is headed for routine testing in addition for those types of deep dive whole genome sequencing applications. So the U.S. food cost of recalls is devastating. Estimated $55 billion a year annually. About 48 million Americans get sick. We have about 130,000 hospitalizations and 3,000 people die. So this is obviously top of mind concern in terms of risk for almost every food brand in the world, and no one certainly wants to be the next Chipotle, who had obviously quite a devastating recall recently, and their stock took a $10 billion hit. So what can we do about that, and where does next generation sequencing play in this market, in this capacity? So here's a very interesting study looking across a 14-year average of false positive and false negative rates for pathogen testing using existing methods like PCR. And here we're looking across the four common big species in question: Salmonella, E. coli, and its STEX and 0157, Listeria monocytogenes, Campylobacter, and we're looking at cumulative false positive and false negative rates, which, as you can see, are fairly high when we're talking about high volume testing programs, which almost every food company, when it comes to routine testing, is doing. So we're looking at a cumulative average false positive rate of 3.1%. This obviously has a pretty significant operational costs and impact. If you're getting a false positive and you're destroying inventory or pulling inventory, that's going to have cost and operational inefficiencies that are introduced into your supply chain program. And then more concerning, of course, is the false negative rate of 6.6%, which when you're dealing with false negatives, that's a potential recall waiting to happen when you're not getting accurate information as to whether in your subsampling programs using PCR, if a pathogen species that could result in high risk is present or not, and this can be devastating for food brands and lead to significant disadvantages. So what are the advantages of next-gen sequencing over legacy-based methods that we've been talking about so much on this call? So when it comes to pathogen testing, next-gen sequencing, allows the identification of sequences with high sensitivity, and that reduces the rate of false negatives and false positives almost to zero of the subsampling that you're doing in comparison to PCR or ELISA, where you're getting non-specific amplification of primer sets or antigen antibody sensitivity, and that leads to a higher rate of false negatives and false positives. Next-gen sequencing has a much lower limit of detection because products can be sequenced to high depth on the next-gen sequencing platforms that Professor Goodridge mentioned from companies like Illumina and Thermo Fisher and others, whereas with PCR and ELISA, your limits of detection are higher due to the reliance on things like gel electrophoresis or fluorescence and other environmental factors that can be introduced, and why you see a higher false negative and positive rates in comparison to NGS, which again, while a brand might think is fairly low, when you're talking about testing hundreds of thousands of samples a year, adds up to very high numbers of false negatives that are slipping through your your food safety programs. And then, of course, next-gen sequencing can pick up and track sequence variations within the amplified regions. What that means is you're able to then, consolidate the whole testing process and look at things like serotype information in one single test, so that if you do flag a positive, you're not having to wait for 3 to 5 days to then get that subsequent serotype data that you would need. This is an interesting data set that looks at looks across the limitations of legacy testing when it comes to false negative rates. So here's an analysis of 3 major qPCR solutions that are in the market today. The most common testing platforms that are being used for salmonella and listeria testing. And here you can see the percentage of salmonella serotypes detected, which might seem great at first glance, a 99.2% accuracy rate or a 99.4% accuracy rate in the case of listeria. But when you're talking about, again, the scales of hundreds of thousands of tests a year, that adds up to 600, looking at the listeria case, for example, the listeria mono, that adds up to 600 potential false negatives if you're doing 100,000 tests a year, which is significant and poses a significant risk to recalls for food brands. So with next-gen sequencing of the subsampling that brands are doing, you can bring that false negative rate down to pretty much zero, because again, you're able to read all of the amplicon and sequence information through the NGS platforms. So what I've been going through just now is really dealing with that segment of next-gen sequencing of targeted sequencing, which I personally believe is going to play a huge role in routine food safety programs, in environmental testing and product-level testing, and will probably dwarf the volume of whole genome sequencing, which is also currently being done. But of course, whole genome sequencing is a very controversial topic and deserves our attention today. Just to wrap up, certainly the Genome Tracker initiative by FDA has stirred a lot of attention around this one particular application of next-gen sequencing because it is so useful in the application of outbreaks and foodborne recalls. And of course, this was highlighted recently in the White House Impact Report. As you can see, within the last 4 years, the FDA Genome Tracker database has amassed over 100,000 genomes across the major pathogenic strains. And really the value proposition by FDA and other regulatory bodies using a system like this is to pull in the investigation time substantially from the point where a contaminated food enters the supply chain to tracing back to the source through whole genome sequencing and database querying, and to reduce the number of illnesses and the days of investigation in an event like this. So from a public health perspective, this particular application of next-gen sequencing in food safety, specifically whole genome sequencing, is very powerful. And again, it lets a food company go down to the very, very deepest level of identifying a particular strain. You can think of it as almost like a fingerprint for bacteria that can do an identical match. But of course, this level of resolution is not really necessary for routine testing programs where companies are more concerned really with serotype information, and that's enough. They really don't need to go down to such a deep level. But in the event of a foodborne recall and investigation, it's very, very powerful and a compelling tool. There's no question. And there's real data to back it up. So here we're looking at the number of outbreaks solved over 2 years in implementing a program like Genome Tracker and whole genome sequencing, and of course, fewer cases per outbreak. So the data is real, and the improvements to food safety in terms of recall investigations and outbreaks, there's no question that it has brought tremendous value and will continue to do so. So to wrap up and to open time for questions and for the attendees to weigh in, we're looking at the future and what's happening here, and we're seeing here on this slide sort of looking to what's on the horizon for food safety, and we have divided the world represented here into legacy food testing versus what we're calling kind of food analytics, the integration of software and molecular diagnostics, and then legacy technologies versus next-gen sequencing. And as Professor Goodridge mentioned, we have the platform players, Illumina, Life Technologies, Agilent, others, looking at this space very seriously because they obviously want to sell more sequencers into food labs and to open up this market for their technologies. And then of course, in the bottom left-hand quadrant, we have the world of the existing food testing lab providers, which are also either buying their way into this market or building out their own NGS solutions. And really, from our perspective at Clear Labs, and I'll let Professor Goodridge give his impressions, we see the future at the intersection of software analytics and next-gen sequencing, just because, as we've illustrated in this webinar today, the volume and the richness of this data set is incredible, and the insights that can be gleaned from this data, and of course ensuring accuracy of methods, reproducibility, standardization, all of this requires tremendous software and QC implementation. And so that's where we really believe the future lies. And maybe I'll let Larry add his comments on the safety landscape, and then maybe we can leave time for questions from our attendees. Larry, do you want to go?
Yeah, so I just have a couple things to say. First of all, back to that slide where you showed the false negative rate. False negatives are of concern not just for recalls, but obviously because it could also lead to outbreaks. And you have up there salmonella on the left side of the slide there. We're doing a major project right now where we're sequencing thousands of salmonella genomes from thousands of salmonella isolates. We're really, a lot of research studies in academia have focused on the salmonella that cause the most illness that we commonly see for obvious reasons. We need to find ways to control that. But in so doing, we're kind of leaving out all these other salmonella that don't seem to cause a lot of illness, or at least have not yet caused illness. And so the problem with that is there's a bias that develops, and so test makers, their tests, as is seen here, are not able necessarily to detect these rare salmonella cerevisiae, which could suddenly begin to cause illness. We've certainly seen that in the past, where a salmonella serotype that didn't seem to be an issue suddenly becomes an issue because of changes in food production practices and so on and so forth. So that, I just wanted to highlight that. The second thing that I want to highlight is we've talked a lot about technology, but we haven't talked a lot about regulations and policy. And in order for NGS to be fully, the capabilities of NGS to be fully recognized, there's going to have to be corresponding change in government regulations and policy. So, for example, currently, according to the FDA, if you do a rapid test, that's considered a presumptive test. It has to be confirmed by isolating the bacterial colony and testing its biochemical profiles and serotyping and so forth, all of which we've heard today NGS can do. So the confirmatory testing, which takes another 6 to 8 days, is really a big problem, especially for foods with short shelf lives like fresh produce. What we're saying is with NGS, you could have not only a presumptive, but essentially a confirmatory test in one test. However, in order for that to happen, the government regulations will have to change to reflect that. Also, with respect to the idea of detecting multiple organisms in a sample simultaneously, the regulations will need to change and move away from the need to isolate a colony on a plate, which takes time, but also restricts the test by definition to a particular microorganism. So I think hopefully as this field expands, and it is expanding, it's exploding, government regulations will also change to reflect this new technology.
Fantastic, and wholly agreed on the regulatory piece as being really key, and having certainly bodies like the FDA adopt particular applications of next-gen sequencing in their armament, and USDA is moving in that direction, will hopefully help also spur the industry to start to make that transition off of the legacy platforms and onto the next wave of what's coming in this field. So maybe with that, we can open it up to any questions that attendees might have.
We don't have any questions in the chat window, but if anybody wants to verbally ask a question, please open your mic and address the questions to Mani or Larry.
Don't be shy.
This is really, I mean, obviously we're pretty exciting technologies that you guys have discussed today. We really appreciate you doing this. To what extent do you see the uptake now, either in North America or particularly globally? I know you gave sort of the scope of what the market was, but right now, what do you see the uptake in terms of using this technology as compared to some of the more traditional or legacy technologies that are out there?
That's a great question. It's really interesting. You know, when we, my co-founder and I first started Clear Labs, now about three and a half years ago, there was virtually no discussion around next-gen sequencing, and now every food event or conference you go to, it's a sold-out topic and event, and it's really incredible how fast this has become a sort of front and center topic in the food industry. I would say almost every major food brand that we've encountered at Clear Labs, whether it be a manufacturer, CPG company, or a retailer, or a food lab, at the very least is starting to have a next-gen sequencing strategy in place in terms of how they wish to leverage this technology as it enters the market, and all the way to brands having purchased NGS sequencers and having them in their in-house labs, and many of the more forward-thinking manufacturers and CPG companies are already doing high-volume testing with us at Clear Labs. So I would say that as with any new technology, you're going to have your early adopters, but I think it's almost now universal throughout the market that this is a technology that food companies recognize is not going away. It's here to stay and is really the next frontier. And as it becomes, as you saw from that very first slide that we showed in this webinar, of the plummeting costs and turnaround times, it's just going to become so cheap and efficient that it's only a matter of time before this technology becomes fully integrated and mainstream in this industry. And so I think it's to the advantage of food brands to start to really to think about this very seriously as it's here and not going away. Larry, did you want to add any perspectives on that from your perhaps consulting work with the industry?
Yeah, I mirror that. I think certainly, as you said, it's like at every conference that I go to, it's a major. There's major sessions on that and what it can do, and food companies that I've been in direct contact with are very interested in it. I would just say that I think. And I do say, I think this is why, what is happening at Clear Labs is so exciting, is there is a bit of apprehension in the food industry about the technology because they don't understand it. I like to say that food companies are in the business of making food. They're not in the business of understanding DNA sequencing technologies. So they understand and know what they do very well. They see the potential use for this, but they in my examples or my experience, many companies find it confusing and are also a little bit overwhelmed by the potential infrastructure that needs to be set up for this. So really what's needed is standardized methods, standardized bioinformatic methods, because there's a lot of variation on there. And I really see, so going forward, at least in the near to medium term, I think what will really increase uptake of NGS among food companies is for companies to offer those services, where companies can the food company can send a sample, tell the company what they're looking for, and the testing, the NGS testing, is then tailored exactly to that and done by professionals who completely understand what they're doing.
We have a question here, I think, Mani, that would be directed at you.
Sure.
Is that uptake and excitement being seen internationally as well?
That's a great question. I would actually say that we are seeing, in fact, more uptake internationally than in the States, in Asia, in certainly Europe, where perhaps some of these issues are more of a pain in terms of certainly GMOs in Europe, in Asia, issues in China, and particularly with food fraud and food safety. We're seeing a lot of traction and faster adoption in those parts of the world. I think the U.S. Sometimes takes a more cautious approach when it comes to some of these new technologies, but of course all of the all of the infrastructure is here, the technology know-how, the venture capital investment money, the regulatory backing by FDA and others. And so I think the U.S. is going to catch up fairly quickly and in terms of mass adoption. And just to add one quick point to Larry's comments, I completely second that and believe that another key thing that's really necessary is market education, and forums like this that the GMA provides are so critical to really help educate food companies on the different applications of next-gen sequencing and really differentiate between things like whole genome sequencing and other types of targeted sequencing that are much less risky, with less liability, and can provide equal if not more value. So I think market education is huge in addition to standardization of methods.
We're just about ready to close, but I wonder, just in case there's some other questions, I have one question that I'd like to ask Professor Goodrich. In terms of the research that you mentioned and the thousands and thousands of samples that you're processing from the Salmonella submissions you're getting, presumably that's going to give you a pretty good landscape in the particular sector you're working around Salmonella. And I'm making the assumption here that there's some public money that may be going into financing your work. But regardless, what, if anything, do you anticipate the interest of, for example, assuming this is in Canada, CFIA, in looking at that database and the results and determining whether or not they're going to bring this into more stringent regulatory control? And I think this is a concern of some of the food companies as well, in terms of the proprietary nature of some of this data, whether it's linked to their specific operations and so on and so forth. Do you see any sensitivities around this, Professor Goodrich?
So that's a great question. I don't. We're really the CFIA. So actually, before I get to that, so yes, this is a Canadian-funded project by the agency called Genome Canada, but it isn't a typical academic research project. It has to. There's a lot of industry involvement and government agency involvement. So the CFIA, Canadian Food Inspection Agency, is actually part of this, but we also have partners in the FDA that are involved. And the idea is that we're making, we're sequencing these isolates, and we want to make them available, not so much from the point of view of so that it can be used against food companies, but it's actually where the CFIA and the FDA are interested in the data is precisely because of the information Mahani presented about the false positives. So they want to, they're asking, is there a way we can improve existing diagnostics so that we can decrease the false positives by using this sequencing database that we're producing, at least until NGS becomes mature enough that it's used in the majority of food testing procedures. So that's really where the data is being used.
Okay, well, I think it's time we have to close it down now according to schedule, and I'd like to take this opportunity to thank both the speakers for a very illuminating presentation. Hopefully this was useful to the participants. Thank you for paying attention to the webinar, and I think you will have seen in the decks there that the contact information is there if you have any further questions or follow-up questions, or if necessary you can direct them to the Science and Education Foundation and we'll forward it on. So thank you very much.
Thank you, Brian, and thank you, Professor Goodrich, for joining me today. It was a real pleasure and honor. Thank you.
Thank you as well.